In the following demonstrations, we will illustrate the general procedures involved in braze welding. Braze welding is commonly used in many types of joints, and typically for the joining of different gauge metals as well as different metal types. In the first example, we shall use the braze welding process to join dissimilar gauge steel, namely 3 mm and 1.6 mm mild steel in a T-joint. The metalwork pieces have been cleaned and prepared as explained previously. For this exercise, we shall be using a general-purpose 3 mm non-coated bronze filler wire and a general-purpose flux powder designed for braze welding operations. The nozzle that we have selected for this injector torch is classified as a general-purpose braze weld nozzle. You might also use a number 5 or a number 7 nozzle on a balanced pressure torch. A neutral to slightly oxidizing flame is set. Heat is liberally applied over the full surface area of the plates in order to preheat the work. Preheating helps in reducing stress in the plates and the joint. Notice that the flame is concentrated more favorably to the thicker of the two plates, as this plate will take longer to reach brazing temperature. Preheating is continued until the steel takes on a blue-pink appearance, which indicates that we are approaching the required temperature of around 900 degrees. The brazing rod is preheated and then dipped into the powdered flux. In this way, flux adheres to the rod, which is then carried to the braze area. A small tack is made at one end of the work to secure the plates. The weld begins at the opposite end of the joint. First, we see that the torch nozzle is maintained at an angle so that the flame is pointed in the direction of travel, which, in this demonstration, is the leftward direction. The metal plates are brought to red heat at the point where the filler is to be applied. Filler metal is applied in a dipping action into the heated area. The flame, you will notice, is pulled slightly away from the heated zone as the rod is applied. When extra flux is required, the already heated rod is simply dipped quickly into the flux container. Braze welding is continued in the manner demonstrated until the end of the run has been reached. Another example, which will assist you in attaining good brazing skills, is the joining of dissimilar metals, like this example of copper tubing to mild steel. Preheating of the metal is necessary, but because the steel will require more heat input than copper, heat is concentrated to the steel. Splash heat from the torch flame is sufficient to preheat the copper component. Once the metal approaches the correct temperature, indicated by the colors appearing, then the filler can start to be applied. The filler rod is preheated and flux is collected. Brazing commences in the manner earlier demonstrated. However, greater control of the flame is now required to prevent overheating the copper. It is only through practice that you will gain the experience necessary to manipulate the torch and the filler rod to produce an evenly distributed weld bead. The process is continued around the joint. Once the work has cooled, the residual oxides and flux residues remaining are removed. Chipping and brushing are the normal methods of residual removal. Quenching, using hot water, is an option for the fast removal of flux residues. Allow the work to cool for a few minutes before quenching. If the welded part is to be painted or otherwise coated, then immersion of the cooled work into a pickling solution may be required. Pickling, either in weak acid or alkaline solutions, tends to dissolve any residues trapped within the joint or filler. Completed braze welds should show an even but relatively wide bead of consistent width along or around the entire joint area. The wide bead area ensures adequate bonding onto the parent metal surfaces. Brazing and braze welding are not difficult processes to master, but as with any skill, practice will be necessary. Join us in other Tech AV training productions which are designed to assist you in achieving professional levels of competencies and skills.